Okay guys, let's take a look at our first lesson in this new unit, sequences, series, and summation notation. So first thing, we're going to go over some definitions. You probably have seen some of this in Algebra 2. We're going to go a little bit more into detail though. Let's talk about definitions. So a sequence is our first item. A sequence is a function of f whose domain is the set of natural numbers, which means, 1, 2, 3, 4, 5, 6. They're all integers. The values, f of 1, f of 2, f of 3, are called terms of the sequence. So that's a really important vocabulary word, terms. These little numbers right here, the little 1 and the little 2, little 3, that's their term number. And that usually is one thing that will confuse students, is what these things are for. That's a term number. All right, the nth term of a sequence refers to the formula. You're going to have a lot of problems that say, find the nth term. The nth term means a formula. Okay, so that's how you kind of decode what it's asking you to do. And that formula is going to produce the sequence. A recursive formula. Now let's really talk about this little guy right here. A recursive formula is a special kind of formula. It's a formula that depends on the term before. So when I ask you to write a formula, the only time that you would write a recursive formula is if it says write a recursive formula. Otherwise, we write something called an implicit formula, which will work, it's a more flexible formula. So if I ask you to write a recursive formula and you need the term before to be able to do the formula, and I give you the formula and I say find the 99th term, that's not very nice, is it? Because you're going to have to find 98 terms before you get to the 99th term on a recursive formula. So that's one of the disadvantages of a recursive formula. One of the advantages is they're usually easier to write than an implicit formula. But at any rate, you're only going to write recursive when the directions say use that specific word recursive. Otherwise, it's always an implicit formula. So partial sums means just kind of what it sounds like. It's part of the sum of a series. S sub 1, and this is another part that usually confuses students. So kind of be here with me. If I'm going to add up a bunch of terms of my sequence, if I want the first partial sum, I just write the first term of the sequence. If I want the second partial sum, I add the first two terms, and that result is my second partial sum. If I want the third partial sum, I add the first, second, and third terms, and that result is my third partial sum. So that's what a partial sum is. It's, a part of a sum. So let's see, an infinite series is basically the sum of all the terms of an infinite sequence. It's a sequence that doesn't stop. It just keeps going to infinity. And then you will be asked to write equations for sequences of partial sums. We'll get to that in just a bit. S sub n is the sum of the first 10 terms. What else? Summation notation. This is a sigma. And what the sigma tells you to do is add. This bottom number is the term number that we start at. This particular one is starting at 1. And the top number is the term number that you end at. Okay? So that's how you read this. This is the sum of everything from the first term to the nth term. So that would be an infinite sum. So let's look at some properties of sums. If you have something that's fairly complex and you have the need to break it apart, you are allowed to. There is a property that allows us to break the sums into two different pieces. Sometimes that's helpful to you, if you have something particularly difficult. Same thing with subtraction. You are allowed to break the sums with subtraction. And the only other thing that you're allowed to do is to pull a constant, C stands for a constant, pull that outside the sum. That's the only other thing. It's pretty restrictive. Unlike the limit laws, if you remember we went over limit laws, or we will be going over limit laws, and you pretty much can do just about anything with limits. You can't with summations, just these three things. All right, are we okay with the vocab? All right, let's do some problems. Okay. So these are asking us to find the nth term of a sequence. Now let's talk about, there really are three main categories of sequences. One is arithmetic, one is geometric, and the other one is the gigantic classification of neither. It's not either one. Those are the ones that we tend to have the most difficult time with because there is no formula that we can use to generate the formula. There's no specific pattern. So what we're going to be looking at today is just a combo. We could have some geometric, some pretty simple geometric or simple arithmetic, or just neither ones to write the formula for. So we're asking us to find the nth term, which means find the formula that will create these numbers. When you have a fraction, really the best technique that I can give you is you need to think about the denominator and numerator separately. That's how you would start. Now sometimes they are related. Sometimes the numerator and denominator are related, and you can show a relationship. But the very first thing that I'd like for you to do is you normally start with the denominator. That's normally the best place to start. So let's look at the denominator and see if we notice a pattern going on there. Basically, so we have 2, 4, 6, and 8. So what's happening every time? We're multiplying. Are we adding? What are we doing? Keep adding 2, right? So what we want to do is we want to come up with a formula. This is not recursive. This is going to be an implicit formula using term numbers. So our answer is going to look like that. A sub n equals. N standing for term number. So this is my first term and my second term and my third term and my fourth term. Now let's look at it implicitly. We were looking at it recursively. What is happening every time? Now let's look at it implicitly. How can I generate these numbers knowing that I have to have one of these n's in there? I have to have this number. It's got to be added or subtracted, something to get the 2. This number has to do something to get the 4. This number has to do something to get the 6 and something to get the 8. What could I do to that number to generate all of those numbers? Multiply by 2, right? So my denominator is going to be 2 times n. And then we would check it out just to make sure we're, okay. So if I put a 1 in there, I get a 2. If I put a 2 in there, I get a 4. Put a 3. Yeah, it's generating properly. Okay? So in the numerator, I either need to go through that process again. What do I have to do to get a 1 from a 2 and so forth? Or I have to develop a relationship between the numerator and denominator. In this case, is there a pretty close relationship between the numerator and denominator? Yeah, they are all just one space apart, right? So in order to get these numbers up here, what pattern could I use to get those numbers? Basically 2n minus 1, right? I would take this and I would subtract 1. And that's my formula. We just generated a formula for a sequence that is neither. It's not arithmetic, it's not geometric. These are the hardest ones to do. They are the hardest ones to do, okay? Because there isn't something that you could just say, oh, well, I know it's arithmetic, I'm going to use the formula. You have to generate it yourself, and it's really a guess and check technique to be able to do that. All right, the next one. We have one thing that's a little strange going on, and that's the alternating sign. That's term 1, term 2, 3, 4, 5. Those are our term numbers. So what I would recommend is you deal with the alternating sign first. That will usually help you. It'll help you all the way through calculus. Just deal with the alternating sign first. Now, here are our choices for alternating signs. I'm just going to write them up here. Okay? We could use that. We could use this. Or we could use that. Now those are standard. Certainly there are other things that you could use, but those are the standard ones to use for alternating signs. We need to figure out which one we're going to use. So if I want to put a 1 in my alternating formula and I want to get a negative number, And this one is rarely used in PreCal. It's used more in calculus. Okay. So this one is rarely used in PreCal. We usually use that in calculus, so you can kind of reserve that. You're not going to need that one very often. We're really choosing between these two formulas. All right, so if I put a 1 in, I want to get a negative. If I put a 2 in, I want to get a positive. Am I going to use the top one or the bottom one? I'm going to use the bottom one, right? Because if I put a 1 in here, I get negative 1 to the first is negative 1. If I put a 2 in here, negative 1 squared is a positive 1. See how that term turned positive? And so forth. This is my alternating piece. So I say a to the n equals negative 1 to the n. That takes care of the signs. I don't have to worry about them anymore. Now all we have to focus on is the numbers, the 2, the 4, the 8, the 16, the 32. That's all we need to focus on. We've got the signs taken care of. We can just go on about our business. So now let's look at the pattern. What would I need? How could I generate? If I put a 1 in, I'd get a 2. If I put a 2 in, I get a 4. If I put a 3 in, I get an 8. If I put a 4 in, I get a 16. What could I write to generate that pattern? 2 to the n. So basically, that would be times 2 to the n. That'd be my formula. Negative 1 to the n times 2 to the n. Okay, we okay with that? Like I said, this is the hardest part of the lesson right here, generating these. Once we get past this, it's going to be easier. Questions? All right. Now this one is a recursive formula. So how do I know? It's a recursive formula because, first of all recursive formulas have to give you a place to start. That is like the most missed part on a quiz or a test is students will forget to tell me where they started. You have to write a start. Sometimes a lot of times it's just one number, but sometimes you need more than one number to start a recursive sequence. So this is my start. This little thing right here, the a to the n minus 1, means the previous term. You need to write that down. It means the previous term. Okay, because students really get confused on writing the recursives. This means the previous term. So what this formula is telling me is it's telling me to take the previous term, add 2 to it, and then multiply that result by 3. That's what it's telling me to do. This is a recursive formula. And it wants us to find the first 5 terms. So we'll go over here. So we want a sub 1, which, they already gave us. That's kind of nice. A sub 2, a sub 3, a sub 4, and a sub 5. All right, they already gave us the first term. That is a 1. Now we're going to follow the rule. We're going to take the 1, and we're going to add 2 to it, which would give us 3. And then multiply by 3, that would give us 9. That's my next term. Okay, so maybe some of us need to write it out. Let's write the next term out. So a sub 3 equals 3 times, what is the term before 3? That's 9 plus 2. So that's going to be 11, 3 times 11, or 33. So the third term is 33. Okay? The fourth term, a sub 4 equals 3 times. The term before the fourth term was the third term. So I write that down, 33 plus 2. So what is that? 35 times 3, which is 105. And the last one, a sub 5 equals 3 times the previous term, which was the fourth term, is 105 plus 2. So that's 107 times 3, which is 321. All right, and that's how we work with a recursive formula. We all okay with that? Okay. Now let's start working with partial sums. They want us to find the first 4 partial sums and the nth partial sum. this little word, we just love that little word, nth partial sum. What are they asking us to find? A formula for the partial sums. Now, the formula for the partial sums is not the formula for the sequence. It is a completely different formula. Okay? So, let's do that. We're going to write the first four partial sums. So we're going to write sum 1, sum 2, sum 3, and sum 4. The first four partials. The first sum is just basically the first term, which is 1/2. Actually, it's probably helpful if I just write the terms out. So I have 1/2. The next term would be, 1/4. The next term is 1/8. We need 4 terms. The next term is, 1/16. Okay, is everybody okay with that? I wrote the terms out so that I could see more readily what I'm adding. So to get the second partial sum, I add the first two. 1/2 plus 1/4. That gives me 3/4. Okay, these are a sub n's. Okay, the third partial sum, I'm going to add the first three. 1/2 plus 1/4 plus 1/8. I add all those up and I get 7/8. And the fourth partial sum, and you probably will be able to see a way to like work, do little bits of shortcuts. You don't have to write it out every time, all of this every time, but I want you to be sure you understand what I'm doing. So I have 1/2 plus 1/4 plus 1/8 plus 1/16, and that gives me 15/16. Okay, so what I need to do in order to find my nth partial sum is I really want to write these in a row. You know how like we had these up there? We kind of wrote them in a row and we looked for the pattern. That's what I want to do with this. So I'm going to write this. These are my s sub n's. So it's a 1/2, 3/4, 7/8, and 15/16. My first term, second term, or sum, my first sum, second sum, third sum, fourth sum. So S sub n equals, let's come up with the pattern. When I put a 1 in, I want to be able to get a 2. When I put a 2 in, I want to be able to get a 4. When I put a 3 in, I want to be able to get an 8. What is that saying to us? 2 to the n, isn't it? 2 to the n. And that's on the bottom. So 2 to the n is on the bottom. Now, do I need to come up with a completely separate pattern for the numerator, or are they really tightly related? They are tightly related. They are only 1 apart. So I'm going to do 2 to the n minus 1. And so I have my nth partial sum, and I have my first 4 partial sums. Okay? Those are partial sums. All right. So let's look at the next one. So just for time's sake, let's do the first couple, and then I'm just going to, for time's sake, I'm going to tell you what the others are. It's the same pattern. We're doing the exact same thing. We're going to put a 1 in here where the n is. So that's going to be like 1 minus, 1/2. So my first partial sum is 1/2. And so then we would have, for my second partial sum, I would have 1/2 plus, and then I'm going to have this to go through again. I would do 1/2 minus 1/3. And so I work all that out and I get 2/3. Then partial sum 3, I guess I'll just go ahead and write it down. I get 1/2 plus 2/3 plus, and then my next one for my third one would be 1/3 minus 1/4, and that's going to equal 3/4. And my last partial sum is 1/2 plus 2/3 plus 3/4 plus 1/4 minus 1/5, and that gives me 4/5. So those are my 4 partial sums. I'm going to write down my pattern of partial sums so I can try to figure out the nth partial sum. So we had a 1/2, and we had a 2/3, and a 3/4, and a 4/5. So S sub n equals, that's my first term, my second term, my third term, my fourth term. So again, let's start with the denominator. When I put a 1 in, I need to get a 2. When I put a 2 in, I need to get a 3. When I put a 3 in, I need to get a 4. What should that denominator be? N plus 1. Okay, and again, do we need to do a separate one? Now this is actually working out nicely. Many times we have to do a completely separate pattern for the numerator. But actually, I think all of these cases, they're so tightly related that we can relate them together. And this is the same. These are just one apart. So what can I do? They're just one apart. It would basically be n plus 1 minus 1, which is just n. So there's my nth partial sum. Okay, we okay so far? All right, I need to erase so we can go down to these bottom ones. Does anybody still need that? All right. Okay. So we're going to talk about we're going to do these by hand first, and then we're going to go back and I'm going to show you how to use your calculator. Many of you may already know. Some of you may not know. So, by the way, if you don't have the new operating system for the 84, you really should get it. It will help you tremendously in calculus. It makes your work faster if you have the new operating system. Okay, so let's do the first one. They want us to start with term number 1 and go to term number 5. So writing it out, and you will have these to do by hand as well, and you'll have some to do with the calculator, so be sure you know how to do both techniques. So my first term would be 1. My second term, I put a 2 in here. 2 squared is 4. My third term, I put a 3 in there. 3 squared is 9. My fourth term was 16. And my fifth term is 25. And I have to stop now. Do we see exactly why I have to stop? I have to stop because I've gotten to the last term number that they've asked me to add. So then I add all that up, and I get 55. And again, we'll go back and I'll show you how to use the calculator in just a moment. The next one, now this is very confusing to students. Stay with me here. I start with the third term and end with the fifth. This does not mean that I have 5 terms. It means I end at the 5th term. Okay, so I'm going to start at the third term and end at the 5th term. So the third term would be 1/3 plus 1/4 plus 1/5. And that is going to equal 47 over 60. Okay. The next one, we are starting at which term? The 5th term, and we're going to the 10th term. We're not going to be adding 10 terms this time. I'm starting at the 5th and going to the 10th. So I have 5 plus 6 plus 7 plus 8 plus 9 plus 10. And all of that added up is 45. Now, D is quite strange. We're showing you this because it's an unusual one. It doesn't have a variable, so many students are just like, what? What does that mean? Well, that means that what is the first term? It's 2. And the second term is 2. And the third term is 2. All the terms are 2. So that would be my first term, my second term, my third term, my fourth, fifth, and sixth. It's just adding 2's. And that will give me 12. Okay, so hopefully you have those numbers on your paper because we're going to go to calculator. Actually, let me just finish with the notes and then we'll switch to the calculator. We want on 5A and B, we want to write it like this using sigma notation. So I need my sigma, and you can make it prettier than mine. You know, I probably draw it really nice like they draw it. I want to start at, I'm going to use n's instead of k's. I just like n's. I'm going to start at an n of 1, and I'm going to go to an n of 7. And my formula is n cubed. Whoops. Does everybody see why that would be so? Okay, so you would need to be able to do this, to be able to translate from expanded form to sigma form and from sigma to expanded. Okay, this one, I need a sigma. What term should I start at here? A 3. I should start at a 3, and how far should I go? To 77, and it should be the square root of n. Okay, pretty straightforward. All right, now if you have your calculator with you, I'm going to show you how to do summations in your calculator. So let me get some room here. Okay. Go to your math. Okay, so you are punch the math button, and the summation is down at the bottom of the list. It's 0 on the 84. That's the summation. Now, if you have the new operating system, very easy. It gives you a template. You just fill in the template. So let's do the first one. Go from 1, k equals 1. So we could just use x. X equals 1. 1 to 5. And we're going to put in x squared. Okay? Now, we got 55 when we did that. And that's what the calculator gets. Okay? Let's try the next one. So I'm just going to go up there and reuse that. Just type over it. So we start at 3 and go to 5. And it is I over, so it's, 1 divided by x. Let's get rid of that guy. 1 divided by x. Now if I want it in fraction form, I get my 47/60. Okay? Is everybody okay? Now if you have the old operating system, it is actually much more complicated. If you have the old operating system, there's several ways to get to it, but you have to do a sum sequence, and then you have to type in the equation. Oops. No. You have to type the variable, then the equation, then the lower bound, where you're starting at and where you're ending at. It's pretty complicated, but you can do it. The sum and the sequence are in 2 different places. If you go to list, that's under stat. Here's sequence is right here, number 5 under ops, and sum is number 5 under math. You would have to sum the sequence. Okay, that's what you would have to do in the old operating system. Sum the sequence. So again, it's under list, it's under that menu, and one of them is under ops and one of them is under math. Okay? So you see how the new operating system really saves you time. It really does, because it puts everything in a neat package. All right. Okay, we okay?